Now, these last couple of examples definitely are AP worthy problems, and they all have the same sort of theme, dealing with a square root being in the numerator or the denominator. Could be a cubed root as well, but square root is most common. So basically, the square root of all of this, well, just like we said before, the biggest exponent is all that really matters. So all that we really care about in the numerator is this 5x to the 4th. In the denominator, it's this 4x to the 8th, but it's all under a root. So really this 4x to the 8th, well, it kind of acts more like a 2x to the 4th. Basically, I just took the square root of that first term. The top part acts like a 5x to the 4th, because that's the biggest part. Okay? Well, when its limit as you approach infinity, well, now which is bigger, the top or the bottom? Well, they're both the same as x to the 4th. So that means this limit as x approaches infinity, when we said the exponents are the same, divide the coefficients to get an answer of 5 over 2. I can do the same thing here with my denominator, or I'm sorry, if I have instead of positive infinity, negative infinity, really I'm acting like 5x to the 4th over 2x to the 4th. My exponents are the same. I still have an answer of 5 over 2, even though I'm going to negative infinity. If I look at this problem, again, same idea. My numerator is approaching a, let's make a smaller pen here, 2x cubed. When I take the square root here, square root of 9 is 3, so that's 3x cubed. So this limit, again, with the exponents being the same, is going to be 2 over 3. This one here, same idea. It's approaching or acting like 2x cubed over 3x cubed. So my answer should be 2/3. Here's the issue. With negative infinity, though, we really need to plug in a negative infinity. So if I plugged in negative infinity, I would have a negative up top, but when I plug into my original function, because that's what matters most, I have a square root on the bottom. My denominator is always going to be positive, so this answer is actually going to be negative 2/3. If you go back to this problem over here and check that, if we plug in negative infinity, we have an even root on top, so that's a positive, and we're taking the square root of everything on the bottom, so that also has to be positive. So that's why we had a positive 5 halves for there. So the main thing is checking back with the original. If you plug in a negative value, do you end up with a negative or a positive as a result?